rather than going through and doing them more conversationally, I am going to just kind of show you them as examples really quick. If you find that I went over something a little bit too quickly, let me know. I can definitely go back and give you additional detail as we go. All right, so for this very first one, we have 4 minus, then the parentheses, 5x minus 3. The key here is recognizing that this minus that we have out front there applies to the entire parentheses. And so basically what that means is I'm going to be doing, yes, 4 minus 5x, but I'm also going to be subtracting the minus 3. I don't really want to have to write it like that, though, with the minus. Yeah, so let's go ahead and just turn that instead into plus 3. So notice, when you have a minus out front of the parentheses, it flips the sign of everything inside. Positives become negatives, and negatives become positives. From there, we just combine our like terms. Remember, for like terms, we talked about this on Tuesday, where they just have to have the same variables attached to them. Well, in this case, there's only one term that has the x on it. That's the negative 5x. Notice the negative that's out in front of the 5x goes with it. Whatever sign is to the left of it, that is the sign of your term. And then for the other part, we're going to do the 4 plus the 3, which is, of course, 7. Since it's a positive 7, we say plus. That then is our final answer. That is then simplified. Because for simplifying, basically our goal is just to get rid of any parentheses and combine anything we can. So for this problem, notice we again have that minus in front of the parentheses. But we have to have 2 sets of parentheses. We are going to have to deal with both of them. So first up, I got this 2 out front of the first parentheses. I'm going to be multiplying that 2 into the parentheses. So I'm going to be doing the 2 times the x, which is 2x. And I'm going to be multiplying the 2 by the 9, which is 18. Okay, now the first parentheses is done. Now we go on to the second set of parentheses. It's a minus out front again. So remember, that changes the sign of everything inside. So the 7x is now minus 7x, and the 5 is now minus 5. So notice my first step is just to get rid of those parentheses. Now that I've gotten rid of the parentheses, all it is a matter of combining like terms. So I want to look for the like terms here. If you sometimes have trouble with the like terms, a great strategy is to mark them differently. I'll give you an example here. I'm going to underline all of the terms that are x's, just to make it a little bit easier to find them. And so then that tells me I'm going to have to be doing 2x minus 7x. Notice again, the minus is to the left of the 7x. So that tells me what the sign of the 7x is. So 2 minus 7, that's negative 5. So that's going to be negative 5x. Remember, if they have to be the same, like they both have to have x in them, that part stays the same. So since they both had to have x, they'll both still have an x. The x term doesn't change, like into an x squared or anything like that. And then I'm going to mark the other ones differently, just the numbers. I'm going to circle those. Why? Because I just decided to. There's nothing magic about underlining or circles. It's just marking them in some way that you recognize. All right, so then 18 minus 5 would give me 13. Positive 13, so I write it as plus 13. And it's done. That's it. There's nothing else we can do to this one because we have a single x term and a single number term, and there's no parentheses left. That's what we're going for when simplifying. All right, next problem. Go ahead and write this one down, then we'll work it out together. Now notice this question looks a little different from the last two. One of the things that we're doing right now is we're seeing what do we do when. The skills that we just used were not new. But oftentimes in math class especially, we get used to using just a single skill in a given unit because the teachers decide, okay, in this unit, we're simplifying. Next unit, we'll solve. Today, it's about mixing them up together. So you notice this problem doesn't ask you to just simplify, it asks you to actually solve for x. We have an equal sign in it, which means that if I want to connect the 6x and the 2x, I can't do 6 plus 2. They're on opposite sides of the equal sign. In order to cross the equal sign, remember, we undo it. So I'm going to subtract 2x from both sides. My goal when I'm solving one of these is to move all the x's to one side and all the numbers to the other side. So 6x minus 2x, that gives me 4x minus 1 equals just a 3 left on the right side. I now need to move that 1 to the other side. Right now, that's a minus 1. The opposite of subtracting 1 is adding 1. Okay, we now have 4x equals 4. In order to get the x by itself, well, since it's 4 times x, we're undoing that multiplication, so we're going to divide. So divide both sides by that 4. And so, x equals 1 here. Notice how this answer differs from the last ones we were dealing with. In the last ones, we had an answer that was like 5x plus or minus something. In this case, it's x equals a number. That's what the word solve did for us. The fact that we were solving it meant that we had to have an equal sign. If we have an equal sign, it means our answer is going to be x equals just a number. All right. Next problem. Now this one looks very much like the last one. In fact, our strategy is going to be the same as the last one. I'm going to move the x's all to one side and the numbers to the other side. It's just, I'll tell you right now, we're going to see a little wrinkle. Let's go ahead and just do that. I'm going to move the x's to one side, so I'm going to subtract the 2x from both sides. Okay. Now I need to move all the numbers to the other side, which means I want to get this 8 out of the left and put it into the right. So I do minus 8 to both sides. But this is the part where sometimes people will say something's broken, something went wrong. Because we're left with a 7x on the left side, but on the right side, we're supposed to be doing 8 minus 8. And a lot of people will look at that and say, there's nothing left over on the right-hand side. Exactly. What value is nothing? 0. Actually put in the 0. A lot of people will think, oh, there's nothing left, so I'm just leaving it blank. No, there's a number value for that. Call it 0, and then you can actually finish solving it out, because I still have 7x equals 0 now. I can get rid of the 7 in front of the x by dividing by 7 still. 0 divided by anything is 0. So this one, yes, it builds on the skills from that last one, but it just has that extra little wrinkle in it. I want to make sure you see how to deal with. That's what a lot today is it's nothing really all that new, right? But it is seeing it all together and maybe a few little wrinkles like that. All right. So far, we have simplified stuff that has lots of parentheses in it. We have also solved where x is on both sides. Let's do both at the same time with this one. Go ahead and write this one down, and then we'll work it out together. Now, this is one of those problems where a lot of people might look at it and just say, nope. I don't want to deal with that. But like a lot of math problems, one of the keys to it really is making it into something that's much less imposing. Right now, one of the reasons why it looks imposing to us is that there's all those parentheses. So let's deal with those first. So on the left side, this first set of parentheses that I have right here. Notice there's no number out in front of it, and there's no sign, like a negative, out in front of it. That means that those parentheses aren't really having any mathematical change to them. Technically, we're multiplying it by 1, but of course we know that leaves it the same. So I can just drop out those parentheses and write it as 3x plus 2 there. The next set of parentheses that I have here is plus x minus 3. It's a plus. Because it's a plus out front, it doesn't change the signs. That only changes the signs when it's a minus out front. And there's no number either, so again, this one's basically just multiplying it by 1. So it stays the same. So basically I can just drop out those parentheses. So it's plus x, and then the minus 3 stays a minus 3 there. Then we're going to do the same thing on the right side. So that first parentheses, the 4x minus 10, again, there's nothing out front of it, so it's going to stay a 4x minus 10. But then this last parentheses, notice there is a minus out front of these parentheses. As such, it is going to change the signs of the numbers on the inside. So that'll become a minus 5x and a minus 6. The most common mistake I see on a problem like this is right there. It's forgetting to take that minus and put it on the second number as well. So make sure you're keeping that on your radar as you do these. All right, so I got rid of the parentheses. Well, it's not quite as ugly, but it's still kind of ugly. But we can still improve it quite a bit, right? If I just focus on making each side of the equation as simple as I can, you'll be amazed at how quickly these things start to look very easy. So what I'm going to do now is I'm going to combine like terms on the left side. So I got a 3x and an x. I can combine those. 3x plus x. Remember, x is 1x. So that's going to give me 4x. That's just from doing the 3x plus the x. Now I also have the 2 and the minus 3 on the left side. Again, it's only the left side. I'm only combining like terms on the left. So 2 minus 3 is negative 1. And then I hit the equal sign. So all I did was deal with the stuff on the left and combine what I could. Notice it's already looking simpler on the left side. Let's do the same thing on the right. On the right side, I have 4x and a minus 5x. Those are the two that I need to combine over there. Again, remember that when we look at the 5x, it's a negative 5x because the negative is to the left of that 5. So 4 minus 5 is negative 1, so that will give me negative 1x. If you want to be even better about that, you could just write it as negative x. I'm going to leave the 1 in there for the moment, though, just to make it a little extra clear. But normally I wouldn't put it in there. And then I have the minus 10 minus 6. Okay, negative 10 minus 6, that's negative 16. You should be pretty good with your negatives by now, but if you're still feeling a little bit uneasy about them, try it in your head first, like, okay, I think negative 10 minus 6 is this, and then check it on your calculator. That way you still get to practice yourself to improve your skills, but then you're also giving yourself that instant check to confirm right or not, so that way if it's right, it positively reinforces that for you. And that way you also make sure the math is right as you go. You'll now notice that our equation as we currently have it looks like the last couple that we did, where I just have an x and a number on each side. So I'm going to do the same thing I did on those. I'm going to move the x's to one side and the numbers to the other. So in this particular case, I'm going to choose to move this x from the right to the left. I keep moving them from the right to the left. Do you always have to move it right to left? No. If you want to move it left to right, you can. It'd look a little different from my work, but you'll still get to the same place. And now since this is a negative 1x, if I want to move that to the other side, I'm going to add 1x to both sides. I'm always having to undo what was already there. And so if I do 4x plus 1x, that will give me 5x. Notice the numbers that didn't have x's on them, they don't change because I didn't do anything with them. I see a lot of students who will try to do both at once. They'll try to move the x's and they'll try to move the numbers in the same step. Please do not do that, because the reason why I see a lot of students do it is because I see their work because they called me over to help them because they made a mistake. By trying to do two things at once, you're just more likely to make an error along the way. Whereas if you do one thing at a time, you're able to focus on one thing at a time and you're more accurate. Okay, last step. Actually, no, it's not the last step. Second to last step. I need to get the numbers to the same side, so I'm going to add 1 to both sides in order to move it from left to right. So that gives me 5x equals negative 15. And now onto the last step, because I need to get rid of that 5. So I'm going to divide both sides by 5. And so x equals negative 15 divided by 5. Well, a negative divided by a positive is a negative, and 15 divided by 5 is 3. So x equals negative 3 here. And then that one is done. And now we continue with the solving theme, but all of a sudden it looks quite a bit different, right? We no longer just have an x plus a number on each side. We got fractions. And I know, some of you, as soon as you see the fractions, you're like, no, I don't want to deal with it. But it hopefully is going to be easy. And for some of you, it is easy, but not for everybody. And that's a big point I want to get across here, is that while it might be easy for you, it's not easy for everybody. Now, with this particular one, you might even be able to just look at it and know the answer, but I want to show you the algebra involved. Can you do that? All right, so whenever you see a fraction equal to a fraction like this, we are going to solve it by cross multiplying. That is, I'm going to multiply diagonally. Now this, of course, is a skill that I'm sure you've seen many times before. The error that I most commonly see when people do this, though, is that I see a lot of people that'll say, okay, well, 2 times 12 is 24, 3 times x is 3x, and so they give me this. Nope, not good. Because notice, our original problem had an equal sign in it. Our work here doesn't. You cannot ever get rid of an equal sign out of an equation. It's impossible in mathematics to actually get rid of the equal sign. So if you notice all of a sudden you're missing it, go back and check out what's happening. We do get 24 and 3x in this one, but it's 24 equals 3x. And I could go on about explaining why cross multiplying works, but I'm not going to get into that right now. Short answer, it has to do with multiplying both sides. So we have 24 equals 3x from cross multiplying. Now that we did that, we can finish solving for x. I have 3 times x. I want to undo that, so I'm going to divide both sides by 3. And so we get 8 equals x. Something I really want to emphasize out of this process, we cross multiplied because the two fractions were equal to each other. This is only when we're solving an equation like this. If I were asked to add the fractions or multiply them or divide them or something like that, I would not cross multiply. Cross multiplication is only for when the fractions are equal to each other. All right, so we got our answer of 8 equals x. Notice my final answer has the x on the right-hand side. That's okay. We can leave the x on the right side. It means the same thing as x equals 8. There's nothing magical about having to put the x on the left. I know we tend to like it that way, but you don't have to. All right, continuing with the theme of fractions, let's go on to this one now. All right, for this one, there's actually multiple methods that people use. If you are looking at this problem and you're saying, I would multiply both sides by x, that is great, and that will work very well. But that's not the way I'm going to show the work done. But if you already were thinking that way, you're good. But what I'm going to show you is a way to actually use what we just did. Because if it was a fraction on the right side, we could know to cross multiply. Well, it is a fraction, we just haven't written it as a fraction. Because if you ever want to take any number and write it as a fraction, all you got to do is put it over 1. Because anything divided by 1 is itself. So 2 divided by 1 is 2. Now that we did that, we can now cross multiply and solve it just like we did on the last one. And so to solve from there, I cross multiply. So I do 6 times 1 is 6, 2 times x is 2x. Then divide both sides by 2. So 3 equals x. Okay, next problem. Write this one down. Same kind of an idea, except there is one new wrinkle in there again. And when we see this problem, the question that comes up, if a question is going to come up, is, where's the negative go? The question is always one of, is that negative going to go into the top, the bottom, or both? Well, let's start by looking at this possibility. What if we put the negative into both the top and the bottom? What's a negative divided by a negative? A positive. So negative 1 divided by negative 5, that would actually be a positive 1/5, not a negative 1/5. And so for that reason, it would need to go into either the top or the bottom, but not both. Technically, we could put it into either the top or the bottom, but I'll tell you, I always just put it in the top. There's a couple of mathematical reasons why I like that. It helps when I remember multiplying as well, but I suggest just put it in the top. And so if I then take my original problem and just write it as 2 over x equals negative 1 over 5 like that, I just got rid of the question mark that I had about how to deal with the negative. And now we can solve it like we normally would. So, once again, finish solving it out from there. And so again, we cross multiply, so 2 times 5 is 10. Negative 1 times x is negative x, or if you prefer, negative 1x as well. But every now and then, sometimes people get thrown off by this too. I got negative x. How do I get rid of the negative? Well, remember that negative is really negative 1 times x. So if you ever want to get rid of that negative, divide both sides by negative 1, and that will get you there. 10 divided by negative 1 is negative 10. And so x here equaled negative 10. All right, write down this problem. Again, looking at what happens when we have the fractions in there and how do we deal with it. And once again, part of what makes this one tougher is that we don't just, strictly speaking, have a single fraction over here. We have a fraction next to the x. Well, how do we deal with that then? Well, if it were a single fraction, we could do this. So let's make it a single fraction. So 1/12 x means 1/12 times x. Remember that I can write this as a fraction, so they're both fractions. So I'm going to make that into 1/12 times x over 1. And if you don't remember how to multiply fractions, the rule is you multiply straight across the top, so 1 times x is x, and straight across the bottom, so 12 times 1 is 12. But the short answer is that basically what we just did is we took that x and we put it in the top of the fraction. Just like we did with the negative, we put it in the top of the fraction. That's really all you got to do there. This stuff is just explaining why. And so once I get that x into the fraction like that, then we solve like we did before. We cross multiply. So 3 times 12 is 36. 4 times x is 4x. Get the x by itself, I would divide both sides by 4. And so 36 divided by 4 is 9. 4x divided by 4 is x. There we go. We're done. All right, so this one definitely looks scarier. But the actual skills that we're going to use to solve it are exactly the same ones that we were just using. I guess there's maybe one skill that we'd have to add to it, but actually it's one that you already know pretty well. So we have x's on both sides of our equation. Well, remember whenever we saw that before, we just moved the x's to one side and the numbers to the other side. I'm going to do the same thing here. I'm going to take this negative 4/9 x on the right, and I'm going to move it to the left-hand side. Well, right now that's a negative 4/9 x. I know there's a fraction in it, but the fraction is still just a number. So the opposite of negative 4/9 x is the positive 4/9 x. I'm adding 4/9 x to both sides. Now, if there is any new skill that we have not yet talked about today in this problem, it's right here. Because I need to do 1/9 plus 4/9. But is that really all that hard? If you have 1/9 and you add 4/9 to it, you have a grand total of 5/9. Now, remember earlier I mentioned, anytime in math, two things have to be the same, it's because they stay the same. When you add fractions, remember you have to have a common denominator? That's because it stays the same. We don't add the 9s because they had to both be 9s in the first place. So, when I do that addition, I end up with 5/9 x plus 5 equals 10. Okay, I know you're still looking at like, yeah, but there's still a fraction. So, I got all the x's to one side. Let's get the numbers to the other side. I'm going to move that 5 from the left to the right. Right now it's a plus 5, so I'm going to subtract 5 from both sides. Fraction doesn't change that. And so the 5/9 x is still 5/9 x equals 5. And before, this might have seemed like it was a little bit tricky, but actually we've already seen how to deal with this. Because if it was just a fraction on both sides, just one fraction on both sides, we could cross multiply, right? Well, we can make both sides be written as a fraction. What is 5/9 x as a fraction? Remember, we can just take that x and put it into the top. So that would be 5x over 9. And what's 5 as a fraction?
5 over 1.
Yep, 5 over 1. We have our fraction equal to the fraction. So having done that, we can now go ahead and cross multiply, just like we did before. And so the 5 times the 9 is 45, and the 5x times 1 is 5x. Last thing, get the x by itself. So, divide both sides by 5. And there we go, that one is done.